2 আর তোমাদের পরীক্ষার বিষয়টা এক্সামটা কবে নিলে ভালো হয় বলো আমাকে।
স্যার 8 তারিখ কি নেওয়া যায়? ওই দিন নিলে একটু সুবিধা হয়
8
আমাদের
তারিখ
জন্য।
8 তারিখ কিবার পরে?
স্যার 8 তারিখ
মঙ্গলবার।
মঙ্গলবার পরে।
মঙ্গলবার পরে না? আচ্ছা, তাহলে আমরা 8 তারিখে পরীক্ষা নিতে পারি। হুম,
স্যার,
8
আমাদের পরীক্ষা
তারিখে
কি গুগল ফর্মে হবে না?
হ্যাঁ, গুগল ফর্মে এমসিকিউ।
তাহলে স্যার তাহলে স্যার যে কোনো সময় দেওয়া যাবে স্যার, সমস্যা নেই।
হ্যাঁ, তোমাদের পরীক্ষা হচ্ছে 20 মার্কের। তো আমি নিব 10, আরেক টিচার নিবে 10, তাই না?
জি স্যার।
28 মার্কের।
জি স্যার, আর অ্যাটেন্ডেন্স 8 মার্ক।
আর অ্যাটেন্ডেন্স 8 মার্ক। তো আমি 10 নিলে ওই সেক্ষেত্রে চ্যাপ্টার 1 থেকে 5টা কোশ্চেন থাকবে, চ্যাপ্টার 4 থেকে 5টা কোশ্চেন, এই টোটাল 10টা কোশ্চেন। তো তোমরা প্রিপারেশন নাও যে আমি 8 তারিখে পরীক্ষা নিব। আচ্ছা, আমি কোশ্চেন করে ফেলবো এর মধ্যেই। কোশ্চেন করে
স্যার
তোমাদেরকে। হ্যাঁ, বলো।
স্যার হচ্ছে চ্যাপ্টার 1 আর 4 তো মোটামুটি বড় দুইটা চ্যাপ্টার স্যার। সিলেবাস আর কি 10 মার্কের জন্য একটু বেশি বড় হয়েছে, কমানো যায় স্যার সিলেবাস
আচ্ছা
একটু
আচ্ছা আচ্ছা,
আমাদের।
তোমাদের পরীক্ষা 8 তারিখের আগে কি কোনো ক্লাস আছে কিনা?
7 তারিখের আগে স্যার এ উইক। জি স্যার।
না না, আমি বলছি 8
না
তারিখে, যেহেতু 8 তারিখে পরীক্ষা তোমাদের, 8 তারিখের আগে কি আর কোনো ক্লাস আমরা পাবো?
স্যার, রবিবার যদি নেন 6 তারিখে তাহলে পাবেন স্যার ক্লাস।
আচ্ছা, তাহলে আমরা ওই, যেহেতু আমি আসলে কোশ্চেন এখনো করিনি, সেক্ষেত্রে আমি অ্যাকচুয়ালি আমার কোনো আইডিয়া নেই হোয়াট টাইপ অফ কোশ্চেন আই উইল মেক। সো ইউ নিড অ্যাকচুয়ালি ইউ নিড টু গিভ মি সাম টাইম, যাতে আমি সেই কোশ্চেন গুলা করে তারপরে হচ্ছে আমি তোমাদেরকে একটা আইডিয়া দিতে পারবো। আদারওয়াইজ আমি বললাম একটা, পরে করলাম আরেকটা, দ্যাট উইল বি ডিফিকাল্ট ফর ইউ।
ইয়েস স্যার, উই ক্যান আন্ডারস্ট্যান্ড স্যার।
তাহলে আমরা আজকে চ্যাপ্টার 2 শুরু করি।
আম্মু, ক্লাস নেই?
হ্যাঁ মা, এই যে আমি কম্পিউটার কাজ শেষ করে
আচ্ছা, দেখতে পাচ্ছ না সবাই? হ্যালো?
জি স্যার, দেখা যাচ্ছে।
হ্যালো?
জি স্যার, দেখা যাচ্ছে।
Chemical structures polymer, structural architectural control. Actually, polymer broadly divides several concepts on scale with the properties defined as well as physical properties depends on the different factors like a molecular
স্যার আপনার স্ক্রিন শেয়ার অফ হয়ে গেছে।
তো এখন দেখতে পাচ্ছ না, আমার ওটা মনে হয় ইন্টারনেটের সমস্যা ছিল। তো এখানে দেখা যাচ্ছে যে মলিকুলার স্ট্রাকচার, একটা পলিমারের মলিকুলার স্ট্রাকচার, সেটা যদি প্রসেসিং এর কারণে বিভিন্ন ধরনের ফাংশনাল প্রপার্টিজ গেইন হয়, স্ট্রাকচার হয়, মরফোলজি, তো দ্যাট মরফোলজি উইল মেক দ্য ডিফারেন্ট behavior like a crystallinity, phase behavior, and it also shows the different behavior like TZTM, and after that we can get the final properties, that means final products we can get. So it depends on the molecular structures of the polymer, and this polymeric structure can be modified by different additives, different chemicals like different monomers, different copolymers like that, and the structural it will get the structural change which can enhance the crystalline or amorphous behavior of the polymer, and the TZ and TM also influenced by this kind of the structural modification. Processing and molecular architecture of polymer determines its function, structure, and morphology, which in turn determines its final properties. The structure determines the polymer physical and chemical properties. So physical and chemical properties fully depends on the molecular structure of the polymer. And you can see that the two different polymers like a polydioxyl fluorine is an electroluminescent conductive polymer which can be used for the emission of blue light and light emitting diodes, LED, that is a blue LED. It can be produced from the polydioxyl fluorine. And also PDMS, polydimethyl siloxane, silicon oil, polydimethyl siloxane, PDMS are optically clear and in general inert and non-toxic and non-flammable compound, and the silicon oxygen bonds makes the PDMS more flexible. And this PDMS, the glass transition temperature of PDMS is 100 minus 100 degrees Celsius. If you consider that the polyamides of the polymers, we know that there are two kinds of polyamides, and one is the aliphatic polyamides is called nylon and nylon 6,6 and nylon 6. So if we compare with the nylon 6, we need the two monomers like hexamethylene diamine and adipic acid. It can form the CONH, which we call the amide bond, and these amide bonds are in the several positions. That's why there are many amide groups are present in the polymer, so that's why it's called polyamides. However, if we consider the benzene ring in the polymer chain, like this benzene ring, when we attach the benzene rings on the polymer, so it's called the Kevlar. Kevlar is very low flexibility, makes it a rigid structure. The hydrogen bonding enhances the rigidity and makes it solvent resistant. The long backbone gives it high mechanical strength. In fact, Kevlar has a liquid crystalline structure. The Kevlar has a liquid crystalline structure LCD, and it can form the LCD displays. The polymerization process of vinyl compounds are head-to-tail addition or head-to-head addition. So there are several ways the polymerization can occur, like a head-to-tail addition, head-to-head addition. We already learned about that. There are several process like a head-to-head addition, head-to-tail addition. And তোমরা কি বুঝতে পারছো কিনা সবাই? শুনতে পাচ্ছো সবাই?
জি স্যার, বুঝতে পারছি।
Good. And the monomer shows in the butadiene, which is used to make the polybutadiene. So these diene monomers are two carbon-carbon double bonds, and they can link together and one way, and this butadiene can form the different ways, like a cis-1,4-butadiene, trans-1,4-butadiene, and 1,2 side vinyl groups. So these are the several structures can form the different can shows the different properties, like cis-1,4-butadiene shows the Tg value is comparatively low or better than the trans. So that means there's a polymer structural difference also influence for the processing, also influenced by processing or different modifications. So it will show the different characteristics. So it is a 1,4-poly polybutadiene, which is the different isomer like cis and trans, and the glass transition temperature, you can see that the one is -102 and another is -58, and melting temperature 1 and 141. However, polyisoprene cis and trans also shows the glass transition temperature -73 and -58. However, melting temperature shows the 28 and 74. So this polyisoprene number cis-1,4-isoprene is a synthetic latex-free number of first produced in 1954, and is the synthetic equivalent to natural rubber. Its properties are similar to the natural rubber and is hypoallergic, and making it excellent material for the medical industry as a latex-free alternative to the natural rubber to -100 degrees Celsius. So this you can see the diene polymer is formed. They can be cross-linked by a process is called vulcanization. This is done by heating the polymer with the sulfur, and the sulfur reacts with the two carbon-carbon double bonds in adjacent carbon chain as shown in the following. So this is called the vulcanization of rubber. Without cross-linking, diene polymer can get gummy. When they heated, they can become a brittle and break when they get too cold. So temperature is also a important factor. It also plays a very great role for the characteristics of the polymer. Tacticity. Tacticity is a relatively stereochemistry. Tacticity is one kind of stereochemistry of adjacent chiral content of a macromolecule. So this tactic macromolecule is a macromolecule in which is essentially all the configuration units are identical. Like isotactic polymer, there are three kinds of the tactic polymer, like isotactic, syndiotactic, and atactic. We know that the three classification of the polymers, like isotactic, symbiotic. Isotactic means when the polymeric chains are in the same side of the substituent, the substituents are same side, is called isotactic polymer. And symbiotic polymers means there are the alternating positions in the substituent in the alternating positions is called symbiotic polymer. And if the macromolecules of the substituents are in the not in the are placed in randomly, is called the atactic polymers. So there are three kinds of tactic polymers, like isotactic, symbiotic, and atactic. And polymer chain structures there are two kinds of polymer structure. One is linear polymer and another is branched polymer. We know that the linear polymers have a high degree of crystallinity and be stronger, denser, and more rigid. And linear polymers have lower chemical resistance than branched chain and cross-linked polymers. In straight chain polymer, the individual chains are held together by weak intermolecular force of attraction. Strength increases with increase in chain length, and as the longer chains are entangled better. Examples of linear polymers are polyethylene, polyvinyl chloride, polymethyl methacrylate, nylon, and fluorocarbons. Teflon. A linear polymer is Teflon, which is made from polytetrafluoroethylene. So this is linear polymers. And branched polymer means when the polymer occurs with a different group units or branch off from the long polymer chain. The branched are known as the side chains and can also be very long groups of repeating structures. Branching polymer can be further categorized by how the branch off from the main chain. Branching chain can be formed with more than two functional groups, in which short chains emerge from the backbone. And another is a cross-linked polymer. An additional type of polymer is known as cross-linked polymer, when the two polymers formed by the long chains and they are connected with the another monomers, another polymers, which is called the cross-linked polymer. The polymer molecule, so is made by chrome, and the intermolecular force cannot break the intermolecular force, always attract the polymer chains, and then the result are becoming more stronger and more stable of the materials. So this cross-linked polymers. And the structural property relationship of polymers, there are different relationship, like a tensile strength, physical properties of polymers. Macromolecules are a wide range of properties which are quite different from those of respective monomers. They may be elastic or rigid, or soft or transparent or opaque, and have strength of steel, but can have very light weight and is also soft on heating, or can set to a hard mass of cooling the melt. Actually, the properties of the polymers based on the several factors, like a tensile strength based on forces of attraction, based on slipping power. So there are three important categories. Can ensure the polymeric behavior. So the tensile strength is based on the forces of attraction of the polymers, polymer molecules, like structural molecules, different structural molecules, and forces of attraction enhances by the different covalent bonds or intermolecular force between the polymer between the molecular chain. And another thing is the slipping power. It depends on the movement of molecules of the polymer and also the shape of the molecules. If first monomers or first molecules of the polymers are too large rather than the second molecule, so there is some gap between the two monomers can enhance the slipping properties of the polymer. So that's why in case of polyvinyl chloride, these are bulky chain, bulky chlorine atoms are present along the chain length, and hence movement is restricted. Slipping power is less, hence PVC has a higher strength than polyethylene. So PVC, important polymers like PVC we can use for in the different you know, the making the door, window, and also we can use the Suarez line, Suarez pipe in our household. So PVC has a good strength than polyethylene because of the bulky chlorine atoms are present on the polymer chain. So there are less slipping power, possibility of less slipping power. So that's why it shows the higher strength. And is another important another important properties are the chemical resistance. Actually, the polymer which have a which has a every polymer has different functional groups like a hydroxyl, carboxyl, amine, or cyanide, and that kind of functional group also attract different solvent which has also the function, which has also a functional group like hydroxyl, carboxyl, or amine, like that. And we know that the like materials attract. That means which one is like the same characteristics of the molecules of the polymer with the different same characteristics of solvent. Like if we consider that the polyester, the polyester has a hydroxyl group, because we know that we use the two monomers, ethylene glycol and terephthalic acid, which has a hydroxyl group. If we dissolve this polyester into the sodium hydroxide solution or alcoholic solution, it shows the polymer will degrade because of the hydroxyl groups, like the solvent hydroxyl group. That's why it can damage the polymeric structures. So is the resistance of chemical also influenced by the functional groups of the polymer. And we can if we want to differentiate between the starch and cellulose, we know that the beta glucose is the monomer unit in cellulose. As the result of the bond angles of the beta acetal linkage, cellulose is mostly linear chain, and starch is called the alpha glucose. We know that the monomers unit in starch. As a result, the bond angles in the alpha acetal linkage, starch amylase, actually forms a spiral much like a coil spring, like a starch. Starch and cellulose are two common carbohydrates. Starch and cellulose are isomers. Indeed, stereoisomers. In cellulose, the oxygen atom joins two rings using two equatorial position, and in such a way that oxygen occupies the axial position, since the hydroxyl positioning down, it gives the chain built in curve. Actually, glucose alpha form when hydrogen chain is in the upper condition. You can see that one. If we consider this one, this hydrogen chain is upper portion and hydroxyl groups are in the upper chain. So that's is called the beta form, and that one is called the alpha form. Then in cellulose, the oxygen occupies the equatorial position, this equatorial position, and this is called the axial position. So equatorial position is the hydrogen, so that is called the alpha glucose. If the equatorial position is hydroxyl, and in such a way that oxygen occupies the axial position, in the axial positions, if in a axial position is hydroxyl, then we call it beta glucose. Hydroxyl group is in here and hydrogen group is in here, is called beta glucose, and hydrogen is in here and hydroxyl is in here, is called the alpha glucose. So that is the basic difference between the alpha glucose and beta glucose. So cellulose is a composed of long chain held together by intermolecular hydrogen bonds, and thus forming the sheets that stack in an extensive three-dimensional network. And these three-dimensional networks shows more stronger bond between the polymeric chain. So that's why the cellulose, actually human being cannot digest the cellulosic material. We cannot eat the grass. But in case of the starch, this alpha 1,4-glycosidic rings junction is a starch creates that chain the fold into a helix. It's a helix bond. You can see that this is a helix bond because of the alpha glucose. In alpha glucose, hydrogen bond is in the upper position and hydroxyl is in the lower position, equatorial and axial position. This, if it happens, then this axial chain make the more bending structure of the starch polymer, so that's why we can digest easily. However, in case of cellulose, we cannot eat because of the alpha beta cellulosic structural sheet it can produce, so that's why we cannot eat. And the low density polyethylene and high density polyethylene, the difference between low density polyethylene and high density polyethylene is a range of 0.910 to 0.940 gram per centimeter. It is not reactive at room temperature, except by a strong oxidizing agent, and some solvents causes swelling, and it can withstand temperature of 80 degrees Celsius continuously and 95 degrees Celsius a short time, made a translucent or opaque structures, opaque variation. It is quite flexible and tough. LDP, low density polyethylene, and another is a high density polyethylene. So high density polyethylene can range from 0.93 to 0.97 gram per centimeter, and HDP has a little branching, giving it stronger intermolecular forces and tensile strength than LDP. HDP is used for food storage container, fuel tanks, and folding chains. So that's important. There are several uses of the high density polyethylene. If you have any question, please don't hesitate to ask me. Actually, we have another important topics remain, like a characterization of polymer structure. There are two methods actually used for the FTIR. FTIR recently purchased from the Canada in our Butex. So you can also see the FTIR machine in Vortex. And if you want to see the NMR machines, you have to go the BCSAR. That means science laboratory. So next class we'll study about the IR spectroscopy and NMR spectroscopy and the principle. How can we use and how can we get the results from the different curvature. So if you have any question with the chapter 1, so please don't hesitate to ask me. হ্যালো, শুনতে পাচ্ছ সবাই?
Yes, sir, we can hear you.
ওকে, তাহলে আমরা কি আর কন্টিনিউ করব নাকি আমরা আজকে স্টপ রাখি?
স্যার এতটুকুই থাকুক আজকে।
আজকে এটুকু থাক। হ্যাঁ, ওকে, থ্যাংক ইউ ভেরি মাচ। নেক্সট ক্লাস হবে নেক্সট কবে বললা তোমরা? মঙ্গলবার।
স্যার মঙ্গলবার হচ্ছে এক্সাম দিতে যাচ্ছিলাম স্যার।
হ্যাঁ, মঙ্গলবার এক্সাম আমি কোশ্চেন করে রাখবো, এই সপ্তাহের মধ্যেই কোশ্চেন করে ফেলো সব। কোশ্চেন করে তুমি আমাকে একটা ফিক্সড ডেট বলো, আমি তোমাদের সাথে আলোচনা করবো যে কি টাইপের কোশ্চেন হতে পারে। অ্যাকচুয়ালি আমি জানি না যে কি ধরনের কোশ্চেন হবে, খাতা কোশ্চেন করতে গেলে না বোঝা যায় কি ধরনের কোশ্চেন আসতে পারে।
জি স্যার, আমি স্যার আপনার সাথে স্যার ফোনে কথা বলে নিব স্যার ক্লাসের আগে।
ওকে, থ্যাংক ইউ ভেরি মাচ এভরিওয়ান।